Welcome to Tutorial 5. Tutorial 5 will be given by Wei Ding, and unlike what you read in the program, is no longer at New York Institute of Technology. Don't ever believe what you read. He has just switched universities to Florida Polytechnic University. You see the beautiful landscape he sees from his bathroom window at his home. And he will give a tutorial on sensor network-centered integration of RFID and WSN for application in consumer electronics. And welcome, Dr. Ding, and thank you very much for coming here.
Thank you. Okay. Sorry for the last-minute change. That actually does not really affect anything about the content. So we have pretty flexible timing, so you can ask me anytime you like. So we should have plenty of time, even go to the details. So let's start. And good morning. And my name is Wei, and here is my outline for today. First, but I guess if I have shorter time, I probably will skip the first two parts because they're very, very fundamental. And I believe majority of you are pretty expert in all these things. So, but since I have time, let me know if you get bored, because these are very fundamental first two parts. So I will first introduce the very basics of RFID and its application in our consumer electronics. And similarly, we'll do a very basic intro for the sensor network and its application in consumer electronics. Then I will go to the existing approaches of the integration of these two technologies. Then, but the focus will be on our sensor network-centered approach. We believe it's compared to all the literature we have read, it's fairly new. And then we'll do a little numerical or quantitative analysis about its gain. Then at the end, after the gain analysis, we'll go to the about hardware, the foundation, how we can do that. The foundation is we have to wear the RFID tags directly with metal wear to the sensor nodes. And we recently, last year, we done some experiments. And we showed the data. Then at the end, we concluded, as I just said, we should have plenty of time. And so feel free to ask whatever question you may have. So first, about the RFID technology, this is so common. And just let me know if I can skip. Yeah. The purpose is to locate the things normally it's not easy to locate. And we normally use the reader and the tags and assign the ID, whatever the normally supposed to be unique ID to the tag. Then through the radio, the reader would find the tag and attach that ID to, actually not to the tag. Very few cases we only use tag. The tags normally attached to the object we want to identify, we want to locate. So, and this technology has been there a very long times. And so nothing really new. And here the typical diagram, this is for the passive tag, and I do not think I really need to go into there because you are probably more expert than myself. And so the basic idea is it's done through the radio, either near field or a little bit different, but basic idea through the radio. And for passive tag, the power is gathered through the radio as well. Then this power would drive the circuits in the passive tag, then passive tag send back the ID and probably some other information. In this project, we always assume there's some other information that later on we'll give the detail. Then these are the very common stuff that everybody knows. And there are three kind of tags: passive, active, passive without power. Active with power, hybrid has some power, sometimes later to wake up, sometimes later sleep. Then the frequency is always low, high, and ultra high. And nowadays, probably most people would go with ultra high. Then in the standard, we would really have no. Actually, these are not real. I believe more popular in industry should be the EPC standard. It's not really ISO standards. Then the applications, so far, so many. And the supply chain, inventory, storage, retails, I believe mostly tracking the product. And later on, what I want to emphasize is with the help of the internet and the wireless sensor network, this RFID right now we can use for trace the entire life cycle of most consumer products. That's the and this our contribution would make it more cover almost entire the production cycle from the production to the end to the garbage bin. And the users pretty much cover everything, but just several years ago, probably only on the manufacturer and the retailer side. Now we can cover the consumer side. Then that's what basically we break down the functionality, the tracking, the configuration. Configuration nowadays, a lot of the consumer electronics can be consumed. I believe there's a lot of cell phone can be done this way. You call, actually, when you call, make a phone call to customer service, they use radio. They can do something to change actually the product inside. Then the update, similarly, then secure authentication. That's a pretty hot topic. Then integrate. We probably need some examples. Servicing as well. Then for the sensor network, do I need to go in? But anyway, let me go through it. The sensor networks, as most people know, similar to the, I guess, the DoD has contributed a lot to the modern technologies. Like the most famous would be the internet, ARPANET. Then the sensor network is another, probably also be a famous example. At the very beginning, it is primarily almost exclusively used in military applications. This picture shows a standard scenario for application. Our side airplane or helicopter drops thousands of maybe more the sensors on the enemy side. Then after they landed, they turn it on power, turn on radio, then they connect into a network. Even though each sensor node is very cheap, but when these hundreds of thousands of sensor nodes combined together, they could be very powerful in like a tracking and surveillance the enemy vehicles, tank, Humvees. Even nowadays, I believe we can even do with the soldiers, inventories, a lot of things. But nowadays, in past decades, I believe right now the most popular or the biggest usage would be in the healthcare or the medical area. And these are the applications. And we will, for the consumer electronics, we probably only care about the last two. But even though a lot of the application nowadays, the mature application in the healthcare applications. Then the tracking and the monitoring are probably the longest and the most classical applications. Then, but before we propose this idea, I believe the sensor network mostly for the consumer electronics mostly concentrated on the manufacturer side, some in the big retailer side. But our approach could, I believe, could significantly expand its application into the transporter and the consumer side. Then about the existing technology or the approaches for the integration of a sensor network and the RFID technology. Here we first compare their similarity and the differences. The similarity is they both actually, I do not know, it's accident or it's really the top level design, I do not know, probably not the case, probably accident. They're both actually based upon the idea of the small form manufacture and the small size and the lower power. And that is how they become, I believe that is how they become the popular, both RFID, cheap, small, and you can throw them whatever, everywhere, and they can cover, this way they can cover a big area, even though each one has a very short range. Then the sensor nodes normally are more autonomous. They always have the processors, has radio, has memories, but not like for the RFID side, the tag normally has most cases does not have a processor. Nowadays, you can see more on the both tag and the reader sides. And for the impacts, we believe that they both, especially the sensor networks, has been quite a lot emphasized in the new, or actually not really new, just word new, the name is new, like embedded system, now we call it a cyber-physical system, and the Internet of Things. These are, all of them should, based upon the sensors and the connected sensors, that's sensor network. So they should have also they would, this way, if we infer this way, they also could have a big impact on the big data side, because all the collections from the sensor side could become huge. Then their difference is the sensor nodes has more power, normally has more power, has more autonomy, and the RFID is more controlled by the either outside or the human. And we believe not only from their natures, especially from application viewpoint, the integration of these two technologies would provide a lot of new fancy stuff, new perspective for the lot of applications, especially on the consumer electronics. I'm sorry. And here are the 4 existing integrations. Then I give our integration. The first approach is we integrate sensors into tag. So this is centered on the framework of RFID. So the only thing new is actually a lot of tag has been done this way. You put say temperature sensors, the pressure sensors into the tag. And I believe the Intel and the U Washington has made a special things later on, but we probably will not go into that side. That makes it pretty fancy. But that's the one extreme or the high end of this paradigm. Then all other things the same. So there's actually no sensor nodes, only sensors. Sensor without processor, normally without memory, only sensor integrated into the tag circuits. So it's purely still, everything is powered by the radio for the passive tags, then come back. Then the second approach is we integrate the RFID tags with the sensor nodes. In this approach, the sensor nodes would take a more important place, and the tags will become less. In this approach, actually, there's several sub branches. Like you can either, after this, the framework, you can put the sensor connect back to its sensor network, but most likely in previous research was the literature I read, still go back to the readers. That's the. Then the third approach is we integrating the readers we connect readers with the sensor nodes. So just put the sensor node at the next layer of the readers. Like the previously that was the readers just go to the gateways or the central controller. Then we add a sensor node layer. This way actually I believe the purpose is still expand the coverage, but compared to our approach later on, we'll talk about this, does not really change anything about the cost. Then the mixed up the RFID and the sensor networks, that is normally called, in I believe the popular name is RFID networks in the several approaches. And all of them actually mostly based upon this architecture. Like they still mostly go to the readers, then go to the base station. The sensor nodes just used as a accessory in this diagram, either in like this place or this place. So it does not really change the major architecture of the RFID system. Then here is our approach. Our approach is we call it a sensor network or sensor node centered integration of RFID and the sensor network. This approach, our fundamental difference is we can abandon the readers in this diagram. We use sensor nodes mostly. Then later on will give the option of adding readers, but we can safely discard the readers, only use the tags and the sensors. And later we'll show why how and why and what's a good thing of doing so. So this is our summary. Our approach is we think it's new because we have not really seen any similar thing on the literature review and so far. From we have some papers in last year, but still do not have seen anything very close to our work. And there's two things new besides the change to the architecture I just mentioned. Another thing new is we use wire instead of use radio to connect the sensor nodes and the tag. And you certainly would ask why. It looks like a backward step. The one major advantage is this way we can connect all kind of tags, no matter whatever the frequency they use. Because at the end, they all burn down into the voltage or currency. So we could compatible with all kind of tags. And also later on, even bigger impact is the cost. With a given coverage, our experiment shows we can reduce the cost about 1 magnitude. And similarly, we also, if with the same cost, we can increase the coverage about 1 magnitude. So it's about 10 times. And this is what I just said. And here's our details. We provided the detailed designs. One use the passive tag, another use the sensor integrated passive tag. This actually is a very similar thing as we mentioned in the first approach. In the first approach over here, the class 1. I'm sorry. Big mistake. Our first the detailed approach is using the the sensor integrated passive tag. There's a little difference between our approach with the class 1 I just mentioned in the previous list in the 4 existing approaches. The first is the data flow is directly going to the import of the sensor nodes, and it is through the wire. As I just said, it's not through the radio. We actually abandon the radio from the sensor nodes to the tag. And also, another big difference is we discard the readers, especially from the previous architecture. We do not need a reader anymore. So if you look at the backbone, it's become a real sensor network backbone. The tags only used at the last mile or the last 10 millimeters of the entire system. Any questions so far? Or as I said, we have plenty of time. Then, after this, we have 2 more detailed options provided to our user. One is using the multiple readers that's how we stimulate these tags. We can either use readers. So readers will be served as the transmitter of radio in the diagram. So we put readers back, but still back into the sensor network framework. They just serve as a power supplier. Another is we still abandon the readers, just only use the sensor nodes. Use sensor nodes because every sensor node has a radio. Use the transmitters of sensor nodes as the power supplier for the passive tag. So that's then mostly our experiments using the EPC class 1 generation 2, that's a real world standard so far. And here after we shift after adopting our approach, the architecture looks like this. Another approach is we do not need a sensor, only use tag, which we actually implement one application for the blind guide. That the project was done with my previous institution, New York Institute of Technology. We did it in Central Park, but now probably not be able to get back anymore the data. Then another approach is, as I said, if you compare these 2 diagrams, the only difference is the sensor is not inside the tag. For this first approach, we put a sensor. Normally, as I said, I believe nowadays most of the passive tags already have the sensor, and a lot of them have more fancy sensors. But this approach, we do not have any sensor put into the tag. This way would further reduce the cost, and especially for those applications, as I mentioned, need a massive number of the tags to cover the big area, like I said, the blind guide we did. Then, actually, any other question? This is a question that we most commonly have been asked. Any other question? Why we directly wire the sensor instead of use a radio? The answer, as I just said, is so this way it would be compatible with whatever kind of attacks. Actually, if you want to use the active tag, it's still okay, but it does not make sense for the cost efficiency viewpoint. So it's this way we can use whatever ever produced the tag into our system. So the frequency is not a problem at all. And secondly, the cost would be dramatically reduced, as we said. And also, it would save a lot of power, but this does not really affect much about the cost, because this way we only need to say when we need the signal, when we need the data, then we turn on the radio of sensor nodes. That's totally controlled by the programmer. We do not, like readers normally does not do this. Readers keeps constantly sending out the radios. And this also could reduce the collision problem on the physical layers. Then for the reader deployment problem, actually, in our approach, as I just said, we do not really need a reader. But if we decide to put reader in this picture, then we have multiple approach to deploy readers. In both the approaches I mentioned, reader, and actually the reader actually is not really indispensable. This sentence is not good. Yeah. Reader actually is dispensable. The similar devices, I would say the radio transmitters is always indispensable. As long as anything can provide the transmitter, the reader actually in our architecture is not really that necessary or essential. Then there could cause several problems could cause several update or the need of update in the routing protocols, MAC protocols, and antenna designs. If I believe if we use a smart antenna, which we have not done in our experiments, would be better. But so far, not many the smart antenna technology could go into our price range, so that's why we didn't use the real smart antenna in our experiments. And as I just said, in the previous two diagrams, as you just go back, you can see there's no much difference. So our experiments in both the gain calculation and the hardware, the feasibility experiment, we do not really differentiate these two architectures, this one and this one, almost the same. Then we go to get the quantitative analysis of the coverage gain. It's a pretty simple arithmetics, and we have done quite several experiments with several different applications. So the first is the reader we do the experiment with a reader inside our system. Second, with a reader separately. So you can, cause the readers right now it is only served as the radio transmitter. So it can be, you can put on any place. For our experiment, we first try to put the readers on the node. Actually, that essentially actually eliminates the need of a reader. But for the data viewpoint purpose, we just do this way. Actually, there's really no sense in the real world. If we already have a sensor node, then put another reader on that. And here is our calculation. Suppose the n is the number of the passive tags. In our experiment, including this, the coverage gain analysis and the feasibility experiment, we always use the passive tag because the active tags, one is too expensive, second is too similar to the traditional sensor nodes, so it does not really make much sense. And in our most experiments, we just use the 8 tags to connect to the sensor nodes. But actually, you can, because if you like, you can do up to the number of the ports of sensor nodes. Nowadays, I believe a lot of sensor nodes, no matter the the crossbar, actually, they have the crossbar has changed company name, but their family and other, the Berkeley or UCLA based, they mostly would have more than 24 ports. So you can go either probably 24 or 32, but we didn't do that far. And here we use the P nodes and the P tag and P reader to differentiate the different cost. And here the total cost would be the sum of the nodes and the readers and the tags. As I said, the reader actually you do not really need it, so you can even further reduce the cost just to the P nodes and the N times P tag. So the total coverage increase would be, this is compared to without using the sensor nodes, would be like this. So the number, as you can see, would be, at the end, if we burn down all others, not big important numbers, will be about the 10 times. Here, actually, if we use 8 as n, so it's like less than 8, less than 10. But if you put more, you can even get above than 10. So the 1 magnitude. And here are some details of the calculation. I'm not sure if we, if you have interest or you have time to go into it, but these are very simple calculations. I guess it would be too boring if I. But that is the total, the cost. And we actually we did it in 2 ways. One is from the money side, another from the power side, and the number we get from the actually similar numbers from the 2 sides. So the conclusion is, with all these calculations, is with either if we fix the cost, then the coverage could increase about 10 times. Actually, depends on this number. Really, exactly, precisely depends on how many tags you attach to the sensor nodes. Could be bigger than that, could be smaller than that. If we put 8, then about 5 times. If we put 16, it's probably about 10 times. Then similarly, another argument would be if we fix the coverage, then the cost, or no matter it's money or the energy, would go down to about 10% of a previous calculation. So that's the similar further calculations. Then the next part will be this work we did last year from, I believe, from March till October of last year. We did we call it a validation, because all these entire architecture based upon the assumption that you can attach the passive tag directly with the metal wire to the sensor nodes, analog input port, and that whatever the signals we get from the radio from the passive tag, no matter is we did what the voltage or actually currency is also okay. It should be strong enough to make any difference in the circuit, and our experiment shows that it's definitely more than enough, actually. And actually, this number does not really change much, even we increase the distance from the tag to the sensor nodes. So here the two not good color. It is the blue line should use a red line. It's not really good. But as you can see, this is the case that has almost no distance. So there's the tag, the reader and the tags almost attach each other with minimal distances. So this certainly would be higher the inducted the signal, no matter it is currency or the voltage. Then this is the case at about 1 centimeter difference. The one thing to clarify, we used for this experiment because our kit was a kind of older time kit, so we use low frequency sensor tags. So that's why actually we believe we have not done so the experiment. If you use a high frequency or ultra high frequency, the distance would certainly be increased. We get a similar kind of a curve. But we use a low frequency, so it's 1 centimeter. I believe you probably could several times higher with a higher frequency. Then this diagram we did with 2 centimeters. That is a very kind of cost. Our kit was donated by I believe TI. That's about TI's kit, RFID kit, about 7, 8, almost 10 years ago. So it's kind of a very outdated. But if that kind of older kits or the tags would work, I believe the newer tag should be even better for this case for our validation purpose. So that's this way we show we have a solid, the physical foundation to support our approach. And I guess I finished too soon. But I guess a lot of you already get bored, so I better. So that's the conclusion, and we believe it is a new approach and could really, especially from the consumer electronic side of the perspective, because it really helped to reduce the cost and to a very significant number. So we believe it would be a good approach, but we have not really tried in any industrial scale. We all still did everything in the lab. I believe if any manufacturer do it, the thing would be look much better. Now we just use the boxes and off-the-shelf stuff. But that's what we get with current condition. We get this approach would increase the efficiency about 10 times, 1 magnitude scale. And for the further research, I believe the further would be more on the development instead of on the research side. But a lot of other things could be followed on, like as I said, the routing and the MAC layers. A lot of things can be investigated, but it really depends on if you have that's about manpower and support. Yeah. Thank you. Appreciate it.